Hello everyone, my name is HEGEDēS. I'm a researcher here at the university at the Department of Telecommunications and AI. In my prime time, I'm also a freelancer developer working on large language model based applications. And in the next 30 minutes, I would like to talk about large language models, as the name suggests. I will talk about 5 things that will try to translate what LLMs are for you who are not working with these models in practice. First, we will start from the cliche part. Sadly, I have to start with the cliche part, and then we will generally move towards more precise things. So, large language models are neural network models, sorry. Here, we refer to something like that as the neural network. These are mathematical models from the 60s that are trying to mimic parts of the human neural system. Obviously, much less complicated, but still, as you can see with ChatGPT and its competitors, it's a technology that it's able to do quite many things for us. A neural network has inputs and has outputs. As you see, it's not just one value that we can put on the input. So the input is usually what's something called a vector of values, and the output is also usually a vector. And these software models are running on commercial computers in data centers. They are running on high-performance computing platforms, eating up the power capacity of entire cities. The easiest way to understand neural networks are usually with sort of image recognition scenarios, etc. An image recognition scenario might be that I feed the pixels of an image to a neural network consisting of nodes and connections between those nodes. And then at the output, I get something like a probability distribution for categories. For example, if I feed that picture, that one might say that the probability of a dog being in the picture is less than 1%, but probability of being a cat on the picture is much higher. And hopefully, if I've trained, and this is going to be important, if I trained the network correctly, the next picture might correctly identify the dog on the picture instead of a cat. I've mentioned training, and this is very important. These are not standard algorithms that we have here. We have nodes that receive inputs. For example, this node is receiving the input layer values, but this node is not receiving the input layer values, but something that is already transformed by these nodes. And the beauty and why this works is that the nodes themselves are not linear, meaning that whatever I put in here, I cannot sum and divide to get the output value of this node. And the connections also have weights inside, and those are called parameters of the model. There is a function here that is non-linear, meaning that if I add 2 plus 2 on its input, it will not say 4 or any combination of those numbers, but might say 1.4. There is a function, there can be many functions, it doesn't really matter, it's nonlinear. And then we have connections going all across the network that we have to train. What do I mean by training? Oh, sorry. It means that I will have a large number of training data entities, and I will have the correct value for each input. And I use some mathematical magic with cost functions and stuff like that to minimize the error that the network is making. And that's quite important. I have a virgin network in the beginning, just like our brains when we wake up after being born. And then we start accumulating experiences across, and our network changes. The weights, and even sometimes in our brain, not here, the functions themselves in the individual cells also change. So that's classical artificial intelligence. We learn by example, minimizing the error in the training data. However, generative AI is a bit different. We are trying to generate from the output something new. It's not a classification anymore. It's not telling where the license plate of a car is on the picture or stuff like that, but we are trying to take the text and transform and make something out of it. What exactly? In large language or in any language model, we are trying to continue the text that is input. So if I input, for example, to be or not on a language model, again, I will get a distribution of possible continuations. Hopefully, if it's human language that we trained it on, we will continue with or not to be with a high probability percentage and not like 14 euros. And this is important. Terminology is important for us. We call the input prompt, and the output we call here prompt completion. That's important. It's trying to complete the text that we put it in there. And how we teach these models is by feeding it the entire internet over and over and over again. And it will try to guess the next steps or next words. And an additional information is that neural networks are fixed, language models are fixed, so you cannot put on its input you cannot put infinite amount of text on its input, but rather fixed size of input. For example, in modern language models, that is a million token. A token is roughly translates to 4 English characters, and that's an important terminology right there as well. Token is a number that, because computers do not eat characters, they eat numbers. And a token is a number representing a couple of characters. In the English, it's usually around 4 characters. That will be important for me for multimodality, so put that aside for a second. Fixed size input, output also fixed size. Now, output size is much, much less than the input. I told you 1 million here, I tell you 8,000 here. So you cannot, even if you put in the entire Harry Potter books in the input, it will only be able to continue it for the next 32,000 characters, not much more. Those are language models. Let's make them conversational large language models. Those 2 terms will be important, so let's see why. We have big players on the market investing a lot of money to create something out of language models that is useful. So they realize that people don't want it to simply continue a sentence. They want something that you can interact with, chat with. So they are training these models to be a chat bot. And they are training on everything, and with that, nothing. Those are, again, terminology, foundational models. So whatever is running ChatGPT, something called GPT-4, 5, whatever, or running Gemini, the Google Gemini service, there are these models behind them that we summarizingly call foundational models. These are huge models trained on huge amount of data for a lot of money, and they are equally bad at everything. I intentionally use the word bad because they are good at everything, but not as much as an expert, and they do not have the amount of context as an expert. They might be able to solve mathematical problems, but again, they are not really able to solve a new, very specific mathematical problems, but the ones that they have seen similar problems to. Foundational models, yes. We can create language models on our own. They can be smaller, they can be even as small that can run on a computer. They will be obviously much dumber, much slower, and dumber. But they might be more tailored to specific use cases. Who knows? Foundational models are good for everything, and yet again, they are not good for they are good for nothing. The same goes there. These foundational models require hundreds of gigabytes of graphical processing unit memory to run, and every 12 queries that you put into them equals the amount of energy that you need to burn a toast, right? So they are very large. We don't always need that one. And the intellectual property aspect is also interesting because, as I told you, these are trained on the internet scale. Everything that they were able to scrape off the internet, whether that's legal or not so legal, these models are trained on. And as I said, they are originally text-to-text. But in the background, they are calculating numbers. They don't really care if it's text. And we will get to multimodality in a minute. And it's also important to know that I talked about completion, and I talked about percentages, right? And I don't always want the most probable answer to come to the surface. I want my answers to be more creative and diverge from the safest conversational path. I want it to be creative, as they say. And there are parameters that is also part of the input, essentially, and that can differentiate how the generation continues. Do I always take the next most probable word and put it on the output, or at some points I take some detours? That's called temperature. You may also hear that quite a bit when people talk about these models. Now, it's also important to know that models themselves are stateless. Whatever you put on the input, that's the only thing that's affecting the output. And maybe some statistical things in the background. So that's why it's not always the same answer. There are statistics and rounding errors, etc., but only the input that's configuring the output. So the question is, what am I talking to when I talk to ChatGPT? Why is it remembering stuff? Why is it able to parse documents? The answer is that you are not just talking to a model. You are talking to a service. There are a lot of people working on additional features that work together to serve you that experience that you see on ChatGPT. It's not just a model. Large. Very, very large. As I told you, running these models require hundreds of gigabytes of custom hardware in data centers, and just one instance of a cluster or a rack that can run the latest ChatGPT costs, I believe, $250,000. And this is the numbers game part to it. So the players, you see the growth here, and the B is billion and T is trillion, and the English billion, not the Hungarian one. And they are playing the numbers game. There are a couple of implications of that, but that's for another talk. Okay, language models, completion, make the completion into chat. So you're having a chat with a bot, and you see that it's sort of playing a role, right? It's being a helpful assistant. And when I start structuring the input text, it's not going to be just a text anymore, but I annotate parts of it. And I will pay different attention to those parts. For example, and this is not what you see on ChatGPT, right? But if I would deliver you a custom chatbot, I would be able to tailor its behavior, and I would be able to do it many ways, but one of them is putting instructions into the system prompt part. This is hidden from the user, and for example, I can instruct the model to behave like a translator. I can instruct it to translate from Hungarian to English. And this instruction will cause it, most likely, and I'm being statistical directly, most likely it will instruct it not to generate the hello, I'm nice to, can I help, right? So those mannerisms will disappear if I give it a direct instruction, but rather than it will wait for my input. And it will try to behave like the system prompt. And this is how generations will go. This is how your ChatGPT remembers stuff. This is the first call that we make to the model. It gets this part and generates a continuation to that discussion, generates this response. I put it to the screen for you. You type in the following follow-up question. I run it through the model again, but now I run all 4 of them through the model again. It generates the continuation there, and so on and so on. And if I remember, I told you nowadays, in October 2025, this can go on for a long time, because the input context window is roughly 1 million tokens, or 200,000 most of the time. And hopefully, if I start behaving out of context or out of instructions as a user, we don't know what the model will do, right? Hopefully. But again, it might do the translation because the system prompt instructs it to, but this is where the statistical parts become interesting. How big the temperature is set to, or if I have any other trainings in the model that restrict answering outside of the system prompt instructions. So what happens if I select another role? Hopefully it will try to play that role then. For example, if I talk about you are being a helpful assistant for BME students, hopefully it will only detail about BME and not the price of the fish. Hopefully. So, a couple of myths to bust here. Large language models have emergent tendencies. We tend to say that they are emergent intelligence. There is a scientific argumentation there that I don't want to get into. But yes, as the size grows, as the knowledge accumulated in the neural network grows, we see signs of reasoning, planning, being debated actively what that is. And then we see people trying to use those abilities and make agents. AI agents are LLM prompts that have access to tools, can make decisions what tools to use in what sequence. And then they will try to facilitate, for now, the user intent. But again, there are fundamental issues, whether it's real intelligence, how much it can think outside of the trained box, etc. And what is, however, more important for you to understand that these models are playing the role that is given to them. And usually we ask them to play a persona. In ChatGPT, you don't say that, or you don't see that, because in the background it says, you are a helpful assistant. That's developed into it. And why is it not worth putting LLMs in front of legally binding interfaces? Is that they hallucinate and they can deviate from the instructions. And you as a user can jailbreak it, which is essentially hacking with talking to it. You probably heard about it. There were some incidents, legal incidents around it. But these models are neither humans nor, strictly speaking, algorithms. They are neural models, and you have to understand that. So conversational, we discussed. Large, discussed. Language, discussed. Let's strike language out. All right? Why do I say that? Because if you've tried the latest models, you see that it can see the video stream you're sharing it. It can access your screen, whatever. So it's able to understand video, photo, and even real-time audio. Why is it possible? I talked about tokens so that the LLMs don't think about characters or even texts. They get representations of information in numbers. And that number can be anything. It can be a piece of an image. It can be a piece of a real-time text or video. And that's a very funny thing, is that when we start training these models on multimodal training, not just text, but these other modalities, they become significantly more interesting. Just as a human who doesn't have sight learns very differently than those who have. And we can also train them to generate the output multimodal, meaning that that chat, if I go back very quickly to this chat, these messages might have attachments, multimodal attachments. For example, it can generate an image, and just the image might be part of the response itself. And that's what you're interacting with right now if you ask it to generate an image, or if you start talking to it real time. Good, we have models. What do we do with it? We want to use it for business. We want to use it for specific purposes. What are the expectations or requirements? We want these chatbots or models, chat models, to lead multi-turn conversations, right? And understand and keep, most importantly, keep context. We want it to be, and this is where they are not good at, we want them to be precise, useful, and make reasonable decisions. For example, the AI agents. We want them to, if we ask an AI agent to book us a flight to, I don't know, Zurich, we don't want it to make a flight booking to Madrid. So precision becomes a very tricky thing there. And this relates to hallucination. We don't want the output to be hallucinated, meaning unfounded facts to be presented or unfounded reasoning to be made. We don't want that. And this is where we struggle, the engineers, to make that happen. However, where we are making some progress is that we want these chatbots to be able to access a knowledge base. We want, and I will talk about it in a minute. We also don't want, but that's going to be a different talk, if I saw the agenda correctly, we don't want the LLMs to be either trained on IP, or we don't want copyright infringements when we train our models, or the big ones training their models. And we also don't want, and there is also a question around whether AI-generated content is IP or not. So those two aspects of IP is very interesting here. And finally, and this is also something that we struggle with as engineers, is we want it to stay, we want the chatbot to stay up to date. If you remember, or if you're aware, ChatGPT was trained by data ending in October 2023, meaning that it doesn't know anything. The model is not taught on anything from the last 2 years. So how can you make it know stuff like that? You can either further teach the model, something we call fine-tuning, which is not that great, or you can feed in the prompt, the additional details required to make an educated answer. So how do we do that? By context engineering. Last year, this was prompt engineering. Now it's rebranded as context engineering. What does it mean? It means that when I have a chat with the model, either myself as the user or the systems behind the service need to feed the additional data to the system, to the chat history, if you remember, to the chat history, so that the LLM can make factual, up-to-date, cross-referenced generations to continue our discussion. So there are instructions, there is data, history, and something called retrieved documents. So how do we do this whole knowledge base thing? What is it that we need for that? We need the LLM or the agent or whatever I want to call it, chatbot, to be able to access resources and search in them. Now they are not, funny enough thing is that LLMs are not strictly IT compatible. So they are very good with languages and language structures, but calling stuff explicitly is not their cup of tea. And especially if you have a chat with it, you might use the different terminology for the same concepts. So you need an engine, a retrieval engine, that is able to look for the document parts that are relevant, but those questions, you cannot use the same exact query words that the user is using. You need to do some sort of semantic search in the database. And this is exactly what we need. This is what the LLM needs. This is what I need, right, as a human. So do the LLMs. And we need to build this database from multimodal data, if you remember. So my documents have usually images in them and text together, and we need these to be semantically searchable. And our large language model is limited in its context understanding and context following, so we need to take into account that the questions that it will ask from this retrieval system might be just as imprecise as what the user is asking. So in retrieval augmented generation systems, and that's how you can talk to your documents on ChatGPT if you upload them, there is an engine that takes the document, chunks it up into certain parts, like a couple of pages together, processes it into this retrieval system, and then the language model fetches these chunks based on the discussion. And the semantic similarity is provided by another engine, okay? It's not the LLM explicitly that's doing this search or similarity search, but another model. And I emphasize model because that's also a neural model, but with a very different purpose. And this is how it works. It generates a dimensional space and dimensional space with vectors and math and whatever, and it will retrieve documents based on semantic similarity. And these two parts of the document will be considered similar, but something talking about the conference here in Budapest will be very far away. So if I put a question like, where was Trump doing something with the press, hopefully these two will pop up, even if they are, you see the terminology, the events, the names of the entities are very different. But semantically, they will be much more similar to an image about a dog. In some president's case, it's arguable, but hopefully it will be very different. And in the end, this subsystem called retrieval augmented generation subsystem or retrieval system will also get the question, it will do the retrieval, and our chat history will be augmented. The LLM will get this augmented chat history somehow. There are many ways to do it, but somehow. And that's how it will answer. And that's how ChatGPT is able to understand your documents. It's able to work with those said documents and even know stuff beyond October 2023. And this is my time for the fundamentals of large language models. Thank you for your attention.